Hello everyone, again we are here going to start the irrational numbers. Some decimals which are not terminating and non-repeating are called irrational numbers. In the previous video we have discussed the rational numbers, the terminating numbers and the non-terminating but repeating are called the rational numbers. But here we are having the irrational numbers. So those decimals which are non-terminating and non-repeating as well are called the irrational numbers. Just like we can see in the example 1.31, 311, 311 and so on. This is non-terminating and also non-repeating. Similarly the pi we are using as 22 upon 7 or 3.14, but it is a non-terminating value. Root 2, 1.414 we are using, but this is also a non-terminating value. Okay, now see, find irrational numbers between the rational numbers. So example, this I am explaining the exercise from the exercise, the question number 8 from the exercise 1.3. We have there the question, find 3 different irrational numbers between 5 upon 7 and 9 upon 11. So what we do first we will divide this 5 upon 7. When we divide, we will get an irrational number. This is an irrational number because this is non-terminating and non-repeating. 0.714285 and so on. This is repeating. After 0.714285, again 7 will repeat because we are giving two rational number. One is 5 upon 7, other is 9 upon 11. So this is 0.714285. After this it will repeat itself. So there is and so on. Similarly 9 upon 11, here we are having 81, 81, 81 and so on. So these are two non-terminating but repeating. So these we call the rational numbers as we are given in the question. So how can we find irrational numbers between these two? So here we have a series, just like this is the first number 0.714285. So we will find here the next number, the number greater than this. So only we change one digit. This is the digit 2 here. Here is 1. So we will change this to 2. Then we'll change it to 3. Then we'll change it to 4. And so on. So many numbers. 0.8181. This is the second rational number. So what we have done here, we can see in the division, this is 0.7 and 0.8. So to reach from 0.2 to 0.8, we have in between 9 decimal numbers. So that's why we change only the after the 0.71. So this number we have changed here. Initially this is 1. So we have written here only 2. So 0.724285 and so on. The next number 0.73. This was 2. Now we have changed this to 3. 4285 and so on. 0.744285 and so on. Many number, infinite number we can find here to reach till 0.8181. So any one digit we can change in between the two divisions. So this is how we can find the irrational number between the two rational numbers. You can see the next example also. Give two irrational number between 0.505005000, 0.52522, and so on. So similarly, what we will do, we will change here 0.5. This is 0.5, 0.5. Here is 0, here is 2. So to reach from 0 to 2, we have again 0 to 1, then 1 to 2. So we will write here 0.50. So next number is 0.51. And all are the same numbers. Similarly, we can write here 0.52, 500, 500, and so on. So these are the two irrational numbers between the two given numbers. So how can we find this? Two irrational number between two rational or irrational numbers. Now some special characteristics of rational number, so you can directly find the answers. Every rational number is expressible either as a terminating decimal or a repeating decimal. Similarly, we can say that if you have any terminating decimal, suppose so many numbers are given to you and you have to classify that the given number is rational or irrational. So first of all, we will check that the number is terminating. Every terminating decimal number is a rational number. So again, we have to check along with it that repeating decimal, it should be repeating. It is non-terminating, so it should be repeating decimal is a rational number. So these are the three properties. Similarly, we have the properties for the irrational numbers. Sum of a rational and irrational is again irrational. Example, you can see 2 is a rational number, root 3 is an irrational number. Their sum will be an irrational number. Difference, product and division of a rational and irrational is again irrational. You can see the example, 8 is rational number, root 5 is irrational, their difference is again irrational. 5 is rational, root 3 is irrational, their product, here we are multiplying both, so their product is irrational. This can be write together only, no calculation. 3 upon root 2, so 3 is rational, root 2 is irrational, their division is again an irrational number. So we can say either the sum, difference, product or division of one rational and one irrational number again is an irrational number. Sum of two irrational numbers need not to be irrational. It can be rational or irrational. Example, 2 plus root 3. The sum of rational and irrational is this complete number is irrational. Similarly, 4 minus root 3, the difference of these rational and irrational is again irrational. So these 2 plus root 3 and 4 minus root 3, these are two irrational number. If we solve them, the root 3 will be cancel out. 2 plus 4 is 6. This is a rational number. Similarly, the difference of two irrational need not to be an irrational. That example again you have 5 plus root 2, 5 plus root 2. So what is 5 is real, root 2 is 5 is rational, root 2 is irrational. The complete number is irrational. 4 is rational, root 2 is irrational, complete number is irrational. Their difference, when we solve it and open the bracket, root 2 will get cancel out and you will have here 1, which is a rational number. Similarly, the product of two irrationals need not to be an irrational. Just like root 3 and root 3, when the same root are multiplied, we have the number without root. This is 3. That is irrational. If you multiply root 4, you will get 4. That is again rational number. Similarly, the quotient of two irrational. Quotient means the division of two irrational. Just like 4 root 2 upon root 2. 4 root 2, this is a rational. Root 2 is irrational. Their product. In the very first step we have discussed this. 4 root 2 rational, irrational, their product is again irrational. Root 2 is irrational, both will cut out and you will get here 4, that is a rational number. So quotient of two irrational is again a rational, is need not to be rational, may be rational or irrational. So these are some properties, so you are able to give the answers directly. Now the important thing is there, real numbers. What are the real numbers? Real numbers, actually the combination of all rational and all irrational number is known as real numbers. So we have a series again here. Till here we have read natural numbers, whole numbers, integer and the rational number till here. But now the greatest group is there, that is the real number. Real number is greatest than all these numbers. We have an example here, just every irrational number is a real number. Yes or no? Yes, because every rational number is a real number, because real number is everything. So every irrational number is real number. So irrational, or we can have a question, every rational number is a real number. Yes, but the converse is not possible. If we are saying that the real number is rational, it is not possible, because real number is the greatest number, so it is not necessary. So real number is not is not. So this is yes. Now here we have one thing. Q is a rational number. Q dash is irrational number. So it is real number is the R is the real number. So real number is the combination of both rational and irrational. This is the number line you can see, guys. 0, 1, 2, 3, 4. Here is all the positive integers just in the form of under root m. Here is, we can also express this minus under root m. So because of this question, you will be able to give the answers from NCERT book and other books also. Now this is the homework exercise 1.2, question number 1 and 2. You are able to give the answer now. And exercise 1.5, question number 1 and 2. With the help of the properties, you will be able to give the answer of this exercise. So this is your homework, and no need to do right now the exercise 1.4. We will discuss it later. So this is your homework. But for the next video, you have to prepare with your geometry box, because we will draw all the rational, irrational numbers and real numbers on the number line. Thank you so much.